Is this a benefit for people who are building and writing their own models?
Oh yeah.
Um, do they need to do this step if they're just forking off a branch of DeepSeek? Is that already baked in? Or if they want to really mess with DeepSeek and do stuff and crack into it, they're going to have to understand PTX a little bit.
I mean, if you want to save money, you should download and install the extension. So it's pretty straightforward. I mean, if you're OpenAI, so Sam Altman just said uh, the latest version of GPT is delayed because they're out of GPUs. So if you're Sam Altman, you're gonna ask your guys to go download the library.
Welcome to Practical AI, everybody. My name is Jeff. I'm here with Peter Lynn. Practical AI is brought to you by Pocket AI. Pocket AI is a tool you can use to edit the weights of your model. With Pocket AI, you can prune over 60% of the weights of your model and increase accuracy. Peter, we have another round of essentially the DeepSeek side of the house here that we wanted to talk about. In particular, uh, the whole concept of PTX. We're back to PTX, which we'll explain, but I think the news is that recently, or maybe it was discovered, that PTX is open source. So give us the landscape. What is PTX again? How does it
Yep.
relate to DeepSeek and Nvidia, and like why does this matter?
So recently, I think just this week, DeepSeek actually open sourced their PTX library. So taking a step back, PTX is kind of a middle layer for NVIDIA. At the very highest level, there's a CUDA, which is all the libraries for things like protein folding, machine learning, like all there's over 100 different domain-specific libraries that CUDA has. So when you use those APIs, it then at some point compiles to PTX, which is a parallel thread execution layer. So basically, you say, "Hey, I've got protein folding. Do this job for me." It goes, "Okay, how do I divide this up across 8,000 GPU cores and do the work?" Right. So it has to figure out like, how do I divide the work up efficiently? Then beneath that, there's the actual assembly layer, which figures out like, oh, you've got a 2080 versus a 3080 versus a 4080. So each one of the different versions has different number of kind of GPU cores and tensor cores, and so it needs to know like, oh, okay, here's the PTX. Here's how I actually compile it and use it for this particular piece of hardware. Because if you've got a 4090 versus a 4070, there's a different number of cores, and so it has to know that when it actually compiles it and runs it.
Okay, so just taking a step back, you've got essentially in AI and machine learning, you've got a series of software that interacts with hardware. So on the far opposite side, you've got data running through a model. The model is code, it's software, right? The model itself uses a framework, which is software. The
Yep.
framework interacts with the NVIDIA hardware, which normally would be CUDA, so that's the highest layer of code.
Yep.
CUDA interacts with PTX, which is
Yep.
essentially like compiling, but it's kind of agnostic to whatever is beneath it, right?
Exactly.
It's doing stuff, and then PTX then relates to SAS, which is essentially the assembling
Yep.
software that interacts directly with the hardware. So it's basically now hardware specific. And
Yep.
so the cool thing that DeepSeek did was they basically skipped CUDA and they went right to PTX, and which made them more efficient. And
Yep.
what you're saying now is because now PTX, or they open sourced this, more and more engineers will be able to determine whether they want to skip the slightly slower orchestrating CUDA layer and go
Mhm.
right to PTX and run things a little faster. Is that fair?
Yeah. Yep. So basically, the library is available, and they have sample notebooks that shows you how to check, is this library loaded? If it's loaded, use it. If not, don't use it. So that means that now anyone in open source can download the library. They can install it on the cloud or on their own system, and they can just run it. And so now you get the same benefit.
Is this a benefit for people who are building and writing their own models?
Oh yeah.
Um, Do they need to do this step if they're just forking off a branch of DeepSeek? Is that already baked in? Or if they want to really mess with DeepSeek and do stuff and crack into it, they're going to have to understand PTX a little bit.
I mean, if you want to save money, you should download and install the extension. So it's pretty straightforward. And if you're OpenAI, so Sam Altman just said the latest version of GPT is delayed because they're out of GPUs. So if you're Sam Altman, you're gonna ask your guys to go download the library.
That's right,
Because
because PTX is very specific to Nvidia, right? And if they're running it on Nvidia, obviously they are running it on Nvidia, then that would make sense for them to try to optimize their
exactly,
relationship to the hardware.
exactly.
Now,
Yep.
does this actually get a little bit into kind of thrift shopping mode where theoretically this should help in Nvidia because more people messing around with PTX is good for Nvidia,
Yep.
but it could also end up in a sort of a thrift shop mode where people aren't buying the new stuff because they figure out how to optimize older hardware and run stuff. Is that possible?
No, because right now the demand, I mean, Nvidia is still sold out for 12 to 18 months. Like if you order stuff today, you gotta wait a year and a half to get delivery. So no, it's just gonna increase the demand for NVIDIA, AMD, and Grok hardware because everyone is gonna be building more models, and if you get more models being used, you're gonna need more hardware. And no single hardware manufacturer can build enough hardware for everyone. So for the next 10 years, we're gonna see more and more people buying hardware.
Okay. And then just give us a little bit of just an understanding at sort of what it means to open source the PTX. Wouldn't NVIDIA be the ones to open source it? And then backing up, how did the DeepSeek folks get access to the PTX layer code to figure out how to skip it? And did they, or were they the ones that outsourced it?
No, so this is similar to when CPUs got faster. So in the past, when I worked on rule engines, I wanted to speed it up, and so I'd actually profile my code and figure out like, okay, where is it using too much memory, and where is it causing the system to like go fetch memory, dump stuff, reload new stuff, and do this stupid cycle of dumping memory, loading memory, dumping memory, loading memory. Because you think like, okay, I can speed it up. It might give me 5 or 10%, which doesn't seem like it's that much. But when you're doing this a million times, 100 million times, a billion times, or in the case of machine learning training, you're doing it trillions of times. So 6% adds up very quickly.
Okay. And just last sort of thing we'll touch on in terms of like what they're doing. I think you were kind of getting into the kind of the memory. Um, Explain a little bit about the flush and reload and kind of how that works and
Yeah.
why it's a benefit, where that 6%
Yep.
or 8% comes from.
So whether you're training or inferencing, the first thing you do is you load all the weights for the models, all the parameters, right? And then as you train it, or if you're doing inference, you're going to take your prompt, you're going to pass it in, and then do all the math, right? But you're always going to need the model weights. It's not like you can run your ML with the model weights because that's the important part, right? And so they figured out like, oh, if we just optimize this and stick the model weights in the L1 cache and never flush it, then we save a buttload of time because you're not like saying, oh, flush all the memory and then reload it. It's like it was already there. Why are you flushing and reloading it? It makes no sense.
And
Yep.
that was how typically CUDA would operate. It would flush and reload all the time, and that's essentially your 6 to 8% benefit right there.
Yep. Well, not only that, so it's not just that you're saving 6 to 8%. It's that that also incurs a lot of heat and also incurs a lot of like extra stuff that you don't realize and it adds up over time, right? So you do a short benchmark, like one of the videos I watched, they did a simple test and it ran basically within like, a couple seconds. Well, a couple seconds isn't really a good test because it doesn't give you the real world benefit. It gives you a kind of a baseline of like, this is the minimum amount that you're going to save. But when you test it for real and you train something for an hour or months, you're going to see a much bigger improvement.
Cool. It's an interesting thing that kind of happened recently, and it's probably going to help, save a lot of power, save a lot of processing time, and of course, the big benefiter is Nvidia. They seem to win it no matter what happens, right?
Yep. Yep.
All right. Well, this is a good discussion, Peter. Thanks for teaching us a little bit about the complexity inside these layers and layers of software. But we will for sure have more to say about DeepSeek and PTX over the next little bit. Be sure to ask questions if you have any. Find us on Spotify as well. We're there on Spotify. And hit us up if you have any questions or topic ideas. Take care, everybody.